Hello, my name is Pedro, and I'll be presenting the work Comparative Assessment of Maritime Alternative Biofuels according to logistic aspects. Between 1971 and 2015, CO2 emissions from the maritime sector raised 76.8%, while the world's overall increase was 31.4%. The International Maritime Organization introduced policies for cutting these emissions. In order to reach the goal proposed by IMO, alternative fuels shall be used to replace current marine heavy fuel oils. In a recent paper, Virgilio presents a study comparing a variety of alternative fuels from a life cycle perspective, which assesses each fuel's impact on environment, human health, and resources. This works aims to do such comparisons, but with different criteria focusing on logistic aspects. The criteria will be storage, infrastructure, production centralization, regularity, and availability. The current fuels on the maritime sector are marine gas oil and marine diesel oil, both petroleum derivatives. The alternative fuels we'll be studying are biogas in its biomethane form, ethanol, biodiesel, and DME, which is dimethyl ether. Biogas is a renewable fuel obtained through fermentation of organic matter in biodigester through an anaerobic reaction. Biogas must be refined to biomethane for its use as a fuel, because of the low percentage of methane presented on the biogas in its initial form. Currently, there are about 200 ships that can run on liquefied natural gas and also can be run, therefore, on the biomethane, which is also it's methane, basically. Production levels are rising, and there are unexplored potential production for the biogas, which could absorb the demand caused by the maritime sector introducing it. Ethanol is a product from fermentation and distillation of some agricultural products, and although being commonly used as a fuel on the automotive sector, it has not yet been used commercially on the shipping sector. For its use, there must be some investment on infrastructure and in technology for converting marine engines for running on ethanol. Furthermore, its production is highly concentrated in America. Biodiesel is a liquid fuel obtained through the transesterification of vegetable oils and fat, and resulting in methane, which is the grade of the biodiesel we'll be studying in this paper. It's produced mainly in America and Europe, but is closely followed by Asia, which is good because it's not a very centered production fuel. Currently, the maritime sector only uses FAME as a blend, but there are already some engine manufacturers that can produce engines capable of running on 100% FAME blends. Dimethyl ether is the least fuel we'll be studying. It's mainly obtained through dehydratation of methanol or directly from syngas, which are both renewable production methods. DME is a gaseous fuel which does not contain sulfur nor ash, so it does not generate any sulfur oxide nor particulate matter, but as it's gaseous, it needs a different fuel system, even though it can run directly on diesel engine without any modification on the engine itself. The methodology we use to compare the fuels is the analytic hierarchy process, which is a decision-making method based on pairwise comparison matrices. This method produces consistent results through objective comparisons of subjective criteria. The method consists on choosing the criteria, assigning values for each pairwise confrontation between the criteria, obtaining the comparison matrices, calculating the consistency index, finding the random consistency index, and calculating the consistency ratio. The comparison matrix is a square matrix composed by the grades of importance on each comparison. The consistency index is calculated using the eigenvalues of the comparison matrix and the number of criteria. The random consistency index is a table number varying through the number of criteria, and the consistency ratio is a ratio between the consistency index and the consistency in the runs consistency index, and it must be less than 10% for the results to be considered consistent. To evaluate storage, it was used the energy density of each fuel for the comparison, which translates to the amount of space on the ship required for storage. For the centralization, we use the greatest share of production for a region. For infrastructure, we did a subjective comparison based on adaptivity, existing infrastructure, and production process complexity. For availability, it was pretty straightforward. We use each field's declared total production worldwide in exajoules. And for regularity, we use the price variation through the historical data between 2019 and 2020. The first step in the HAP evaluation was the comparison of the criteria itself for determining which one was the most important. And we got consistent results. And the most important criteria we found was storage, followed by infrastructure, and then centralization, availability, and regularity. Now, for each criteria comparison between the fuel, we got in storage the best result for biodiesel, which was expected since this was a pure objective criteria in which biodiesel had the greatest energy density. In centralization, again, we got biodiesel obtaining the best results, closely followed by biogas, and DME ethanol, since its production are heavily centered, they got very bad results. In infrastructure, also biodiesel got the best results since it's basically a switch of fuel. You don't need any major change in engines or infrastructure on board, offshore, or for transportation of the fuel to the ports. And for availability, we have ethanol as the best score, since its production is the greatest of the field studied. And for regularity, ethanol did the best again, since its price was the one that varied the least. But this was a pretty balanced criteria. So for the results, as expected from the last comparisons, biodiesel had the best results overall, having been the best in 3 of the 5 criteria and showing good results in availability and regularity as well. So based on these logistics perspectives, and with the criteria considered, biogas is not the most advanced of the renewable fuels, which is an opposing result when compared to the BioDili paper. DMA also showed poor results since it needs pressurized storage and completely new fuel, since its production process is complex and there are not a great energy potential being produced yet. And as shown, biodiesel has the advantage of being very similar to MGO and MDO, enabling its use in current technology, and there is no need of major adequacies in infrastructure for transporting the fuel, storing the fuel, and the onboard storage and engine functioning. So here are our reference, mostly BioDili and the articles from EA. And thank you.